So let's talk about an interesting phenomenon then that's related to these different sensors, and that is spicy and minty foods. So I don't know how many of you enjoy spicy foods. I am not a huge fan, but I'm getting a little bit better. I can eat jalapenos now. So why does it burn? So why do you get a burning sensation when you consume peppers? I mean, it doesn't burn on your hands, right? But it will burn in your mouth, it will burn on your eyes, and it will burn on other tissues. So if you get it in your nose, if you get it near things like your genitals, I know that sounds weird, but just a warning, always make sure to thoroughly wash your hands after handling these. And it has to do with what's called a capsaicin receptor. So capsaicin is the chemical in peppers that makes them spicy. Capsaicin is actually made by the peppers to keep us and other mammals from eating them. But as I talked about in a previous video on the nervous system, this capsaicin fires our sympathetic nervous system, and we get enjoyment from that. So some people actually enjoy this sensation. So what is going on as far as this capsaicin receptor? So this capsaicin receptor is going to activate whenever it's exposed to any of this material. It will activate when it's exposed to temperatures above 109 degrees Fahrenheit. So that's actually a big part of what it's for. It's actually a temperature sensor. So it's supposed to help you determine temperature. And so if you're exposed to anything that's above this 43 degrees Celsius, so above your body temperature, or 109 degrees Fahrenheit, it's going to fire. So this is one of the sensors in your mouth that will tell you things like coffee is hot, right? Or, whatever beverage it is that you're drinking. But it will also fire if you consume capsaicin. And so this receptor is also there to help protect us from capsaicin in something like peppers. And it will also fire if it's exposed to compounds that are found in mustard and wasabi. Now, wasabi that's found here in the States, unless you get genuine wasabi, most of this wasabi that you get, like with sushi, the little ball of green stuff, is actually made out of horseradish, but it does the same thing. These compounds are very similar to the capsaicin molecule. And that's why all of these are spicy, right? So why does it feel like it's burning when you consume these? It's because this is a temperature sensor. And when you consume capsaicin or these other compounds, it binds to the receptor and starts telling your brain that you are being burned, that you are, being exposed to high temperatures. So that's what's going on. That's why you get the burn when you consume these spicy foods, because those chemicals are actually binding to this receptor and firing it off. So what's going on with those mints? It's the opposite thing. There's another receptor that is doing cold, right? So capsaicin receptor is a normally warm or hot receptor. Well, there is a receptor for cold, and the menthol in mints is reacting to that cold receptor and tricking it to make you think that it's cold. So any sort of mint that you consume is going to, that chemical is going to bind to that receptor and make you think that it is actually cold. And it's the same receptor that would tell you that ice water is cold. So this video I'll have linked there. It's actually got the information on exactly what the two receptors are called if you're interested. it's got a lot of the same information of what I just talked about. So what can affect your touch receptors? Well, just like all of the other receptors, age will definitely affect them, but for something that's a little different. So the other senses we talked about, it's a breakdown of the pieces and parts. Here, it's because there's a decreased blood flow that's supplying the nerve cells or the spinal cord. So that's what's actually going to create the breakdown of these touch receptors. Brain surgery. So having brain surgery done can definitely affect your touch receptors because they are connected into your central nervous system. Any sort of nerve damage, whether it's from an injury or chronic diseases like diabetes, will also affect your touch receptors. And these guys are fairly important. Why would reduced function of these touch receptors be a problem? I mean, makes sense to us for vision and hearing, but we don't think about missing our touch receptors other than we wouldn't be able to, like touch things. Well, the thing is that if we are losing our touch receptors, we actually are at an increased risk from injury of burns, hypothermia, and frostbite, because our pain receptors are the ones that are going to warn us if we've gotten past that 113 degrees Fahrenheit, which is basically the temperature that we can really start seriously getting injured from heat. And then hypothermia, frostbite, those are going to be the opposite direction. So once we start dropping into those lower temperatures for the cold receptors, past when they stop working, that's where we can get damage from hypothermia and frostbite. And if the receptors aren't working well to start with, we have that increased risk of being exposed to those. There's a falling risk involved. So this is actually why elderly individuals have an increased risk of falling, because these touch receptors help us with things like our balance. And if you can't feel what you're walking on, that really makes it difficult in order to help maintain things like your balance. And then you also have an inability to determine how injured you are. If you can't feel the pain, you can't adequately tell how injured you are. And that is really a problem as far as not being able to determine these touch receptors if you're not having good functioning touch receptors. There's one last thing that's kind of tied to these touch receptors. These are the proprioceptors. These actually help tell you where different parts of your body are. So your touch receptors are all the ones that are on like your skin surface. And then as we saw, you've got pain receptors in like your organ systems. These ones are going to help you actually give you orientation of where your different pieces and parts of your body are. We don't think about these guys, but they are located throughout our entire body. They give us a sense of effort. So they give us information on how much effort and force and direction that we are putting into, for example, using our muscles. So, what are we doing as far as lifting and so forth? And so they are found, as you can see in the picture over here. You're going to find these receptors in muscles, in the joints, and in the tendons. So they're kind of like built-in computer sensors to let you know, are you stretching these too far? Which direction are you pulling and stretching so that you can keep the damage, to a small limit. And they're going to send signals to the central nervous system, again, so that you don't put in too much effort or force, because these do have limits on how much force they can take before they start getting damage done to them. But like I said, this is also what allows you to tell where your different parts of your body are. This is why you can, for example, move around in the dark, why you're able to do tasks with your eyes closed. For example, if you've ever tried it, I bet you can do the whole test where you put your hands out to the side, close your eyes, and then come and bring your fingers in to touch your nose. You're able to do that because of these proprioceptors, because they are giving you feedback information as to where all the different parts of your body are at any time. And that finishes up the senses part of the biology section. That's all I've got for that.